Hello guys, welcome back to my YouTube channel, and this is day 11 of June daily lead code challenge, and our today's question is snapshot array. So let me explain you the problem statement first. I hope you have already read this. This is of no use. Okay, so let me explain you the problem statement. So what they are saying is you have one array. Okay, you have one array of fixed size. Let's say this is of size 5. 1, 2, 3, 4 and 5, and then you have this array is filled with 0 initially. I have zeros all over. Okay, I have zeros all over. Fine. Then what you have to do, they will tell you what set, like set is one function that you have to implement. In that they will give you one index and value, and you have to set the value at that particular index. You have to set the value on this particular index. But one thing that we need to remember is you have to take a screenshot, guys. Initially the screenshot will be like 0, then 1, then 2. This is just an integer value that you have to keep. But what this mean is this is initially snapshot 0. So initially the values are like 0 0 0, like this, all the zeros. Suppose I say, like after a moment I say set 1 comma 5. That means change the value 0 to 5 at index 1. So at index 1 I will change this to what? To 5. I will change this, and this is still snapshot 0. And if I take the snapshot, then this counter will increase. Let's suppose I have take the snapshot. Snap I have taken. Okay, like this I have done, then I'm taking the snapshot in this case. So this snapshot is increased now, and now this array this array will be having the same values as this: 0 5 0 0 0. And now if I say what I say, if I again say set 1 comma 3, let's suppose, then I am changing it to 3. And if so, this is how I will change, and like I have one function set. According to that I have to change the value of an index to with this particular value. I have this snap. That means you have to increase the snap counter, and like this is the array at moment 0, at snap 0, and this is the condition of array at snap 1. Let's suppose at snap 2, after doing the changes, what we have, let's suppose 1 3 0 0 0. So this array, like this is the array at snapshot 2. So whenever I will call the get function, okay, like get function is what they will give also to us. So when they will say get, they will provide you the index and snap id basically. So what this means is you have to return the value at a particular index and of that particular snap id. Let's suppose if I am saying to you, like generally we see, like you have one array and you have to set the values of a particular index. Let's suppose 0 1 2 3 4, and they say set the value of index 1 at 1 to 5. So we change the value, and like after changing the value they just say get function, like the general get function that we have seen till now in all other questions, in like easy questions. That is like just return the value at given index, like 1 or 2 or 3 or 4. But now the twist here is they are not showing just on a particular index. They are saying with index, along with index you have to give the element or at a particular snap id. Like as I said, you are taking a snapshot. when you are taking a snapshot, this snap id will be increased 1, and when you will take again a snap, this will increase to 2. So you have to return the value of a particular index and of a particular snap id. Let's suppose they say give the return the, let's suppose if they say return like this, like get of value index 1 and snapshot id 2. So that means you have to go to this snapshot id, and then you have to tell at index 1 what is the value. This is 3. So this you have to return. Let's suppose they say return the value of index 0 at snapshot 2. Then you have to return 1. Why 1? Because this is the value of index 0 at snap id 2. But if they say not 2, I want value of index 0 but at snap 1. So in this case I have to return 0, guys. I hope I am clear with this. So not only index you have to keep in mind, along with index you have to care, you have to think about the snap id. So how we can actually uh, think, how we can actually proceed, how we can think of the approach. So I know we are considered considered with the index. Okay, index coming into the picture. I am concerned about the snap id. Okay, I am concerned with the snap id, and I know they are saying to set a value at a particular index. So like the intuition of using map is coming in the mind, like we are mapping values to an index. Okay, I'm getting this. Okay, yeah, at a particular index we are setting a value. Yeah, I have seen this in the map. So can you use the map here? Yes, I'm getting the thought here. I think I can use map here. Okay, so how we can actually think, like how we can actually uh, keep this snap id, I can think here, like I can use a map. In that I can, what I can do at a particular snap id, I will uh, I can have a array at a particular snap ID. So like at snap 0, I have this array. And then if I am taking a snap, then I will increase this snap ID to 1, and I can have this array and I can do the changes, and I can do the changes in this only at a particular snap ID. Getting it? Like this is the array, and every time, like at a particular snap ID, we have this array. So whenever we are doing the changes, we will do the changes in this array, and whenever we are taking a snap, we will increase this id and then copy the same array and do the changes in this. And at the time of returning, we can go to this snap id and just return the value of that particular index. But the constraints here are 5 to the power 5 into 1 e power 4. So it will, and calls that we can make is also same, 5 into 1 e power 4. So this will be 1 e power 8, like near to 1 e power 9. So the space consumed will be hell lot of. So we cannot do like this, like for like if you are thinking like we can do this with map like this at a particular snap id, we can store a array and then do the things. So this will not work like this. So what we can do, guys, so let me come to this thing. You will get a clear picture now. We are, guys, we are, what we are returning in the function get, we are returning the value of a particular index. Are you understanding this much? Yes, I am understanding this much. I am concerned with the value that is stored at that particular index. But this is at snap 0, this is at snap 0, I'm writing it, this is snap or this is moment, like I'm taking the snap and this is now 0, and the values are like this. Let's suppose I'm doing the changes now. They are saying at index 0, at index 0, at index 0, let, if they are saying at index 0, change it with 2 value. So I am going to this index and I am changing it with 2 now. Let's suppose the snap, I'm taking the snap, so id will be id what? Id will be incremented. And if I again take, this will be again incremented. But what I'm concerned with, to this value only at this particular index. So can I do something similar to, like, index, keep it same, and at this index I can just have what, like, this is the snap id, okay, whatever be the value, let's suppose this is 2, okay, keep it 2. And if they are saying at snap 1, change this to 3, so I am storing just this snap id and this value on this particular index. I hope you are getting it. So what we will do, for every particular index, we will store the snap ID and value. So what will happen is, like, if this is the index 1, I will say at snap ID 0, the value is 0. And if in coming future, if they say, like, if they tell, like, take a snap, so this value will be increased, like this snap id is, like, from snap id 0, this snap id will be 1. And if they say set 1 3, so that means at index 1 I have to, like, change this value to 3. So what is snap id now, guys? The snap id is 1 now, because I have taken the snap, okay. Then set 3 at index 1, so this is snap id 1, and I am changing the value to 3. So, like, at every particular index we can have this snap id and this value pair. So we can easily do this using map. So what we will do, in the map, or vector, you can use vector is why vector, because we don't have any negative index, like, the index will be 0 1 2 3 4 like this, so we can use vector here. So what I will do, I will use a vector, okay, I will use a vector, and in that we can use a map. Why map? Because these snap id will be in a sequence, 0 then 1 then 2 then 3, so ordered. So this is how I'm getting the vibe of using ordered map. So in that ordered map, what I'm doing, I'm mapping snap id with the value, so int comma int. Yes, you are getting it now. So we can use this map mp, and we can, so what we can do, we will step 1, what is step 1, initialize. We will initialize with this array with 0. Then if this is a set function, if this is a set function, what we will do, we will just do this mp whatever is index and what is our snap id currently, we will just store the value at this place. And whenever we are taking the snap, we will just return the incremented value of snap id, of, like, snap id that we have taken, that we will initialize. I will show you code also, like, just see what are the steps that we are doing for every function, and how we will actually do this, get how we can actually uh, do how we can actually think of this get, like how we can code it. Let's see that. So to code that, let's see one thing. We are using ordered map to store these snap comma, to use this snap and your values, okay. So this is a ordered map. So this is in one order, like 0 then 1 then 2 then 3. So this is ordered. We know if data structure is ordered, you can use something that is called as binary search. But you, like, if you are doing dedicated binary search, that will, like, complex code. So what we can use, we can either use lower bound lower bound, or you can use upper bound. That is up to you. How upper bound and how lower bound? We know in lower bound, if you want, if I want to get what, index 1 and snapshot 2, for example. So if 2 is there, this will return 2, but if 2 is not there, this will give the value, this will return the iterator or pointer of 1. Like, if the same, if the same sorry, not I mean if this will give either value, what I'm saying, this is index, okay, and this is snap id. So this will give the snap id of 2, if not 2 then greater than 2, but not less than 2. So if in case of 2, if 2 is present, let's suppose the id that, like, we are giving this id 2, okay, for lower bound, if we are giving this id 2, this will go and check if 2 is there. If 2 is not there, this will give the this will give the last one. Okay, so if there not 2 is present, so this will give the last one. So we have to do it minus minus. I hope I'm clearing with this. Like what I'm saying is for lower bound, this will give value either, like if 2 is there, this will give 2, and if not 2, this will give the last iterator in that case. So you have to do it minus minus. And if you're doing upper bound, you are using upper bound. So what you will do, you can actually, like if you want to, so this will, if 2 is there, like suppose if like here snapshot id 4 is also there and value is, let's suppose, same 3. So if you are searching for snap id 2, so this will give the value greater than 2 but not 2. So if you have 2, this will not give you 2, so this will give you actually 4. So you have to do it minus minus, because if you don't have 2 id, so like if 2 is not there but at the place of 2, we know the value will be same only, like 3 only, like this. We know if like if we are not changing the value, so this will be changed as the previous one. So whenever you will use upper bound, and if 2 snap id is not there at this index, so this will give value of greater than 2 snap id. So 4, like 4, it will return, but you don't want 4 4, you want for the previous value, so you can do it minus minus. So this is how you can use upper bound and lower bound. I'm using upper bound in my case. So let's see the code. So code is also pretty easy if you have understood the approach. So what we are doing, we are just using this vector of int comma int map. Why we are using map? Because we want to store snap id in a proper manner, in a ordered form, like 0 1 2 3. So that's why we are storing index and snap id corresponding to values. Then what I'm doing, I am resizing it with the length that we want. Then I am storing 0 at every index of snap id 0, because I know this is what, this first one is your index and the second one is what, your snap id. So I'm storing 0 to every index of snap id 0. I hope I'm clear with this. Then at the time of setting it, just go to that index and snap id and put this value. And we are also using this snap id global variable because we want to keep track every time what is the snap id. Like whenever we are taking snap, just increase the value and return. Like this will not, like at the first time, this will not return 1, this will return 0. Why 0? Because you're doing plus plus, like after returning 0, it will increase to 1. Okay, this is like basic thing. Then at the time of this function get, how we will cope with this? So we are using upper bound. So when we are using upper bound, I'm going in this index. Let's suppose for this index 1, I have multiple snap ids. I have explained you, like initially it will be 0 comma 0, like suppose, then we are returning it 1 then 2, and then we have here 4 comma 3, let's suppose. And if you are asking for snap id 2, okay, if you are asking for snap id 2 and index 1, what is the value? So if you are using upper bound, so if then it will give the pointer of this. So you have to do it minus minus, so it will return this, and this is what we want, the previous values that is already. Because at point 1, this is the value is 2, then at the place of 2 the value will be 2, the same. Okay, so we will like find the upper bound, like in case the 2 is also present, let's suppose. So in this case also it will return 4, because we know this is the upper bound, and this will return the element greater than that particular snap id. So 4, then also we have to do it minus minus. So I think I have explained enough about upper bound. Then we can do this it minus minus, and we can return the particular value associated with this, with that it, that this snap id. Okay, so thank you. And if you have understood, So please like the video and you can subscribe to the channel for such more content.